इथं तर झालंय लाईव्ह दिसतंय इथं 36 सेकंड.
लिंक शेअर करा बरोबर.
ही का
एवढा ऑप्शन 16 ऑप्शन त्यातून कुठेही कशातही काम करतात. स्टार्टअप वगैरे आणि
अरे लिंक कुठे आहे
शेअर
कॉपी लिंक
KPS इंटरनेट. हे झालं
झालं ना. ओके ओके
लाईव्ह.
एकदा स्क्रीन चेंज करून बघ किती लाईव्ह मध्ये दिसतंय का नाही. रॉकेट हे आवाज कसं येतोय.
हॅलो. कुठला
थांब काहीच नको. अरे हे KDMचं घातलंय. इथं बंद करतो का
बंद करा.
नाही इथं बंदच करतो.
अरे भाऊ डोळा उघडा म्हणजे चालू आहे.
नाही मग बंद आहे. हॅलो बोल ना बंद आहे.
जवळ आहे. तू पण जवळ असं बोलणार होता. वॉइस थोडा अनक्लिअर आहे.
अरे ते ह्याच्यामुळे रे
त्याचा आवाजच नाही येत. हा खरखरीचा आवाज आहे, वेगळा आवाज आहे खरखर.
मायक्रोफोन डिस्कनेक्ट करायचे का ह्याच्या माईकला कॅप्चर करता येईल ते बघूया. लॅपटॉप माईक एकदा चेक करतो.
ओके येतं आता.
कशावरती घेतो
हे जरा कमी केलं, खरखर कमी झाली.
डिले कमी कर ना वाटलं.
तुझं चालू करते
ऑनच आहे ऑनच आहे
नाही त्या साईडला चार्जिंग नाही घेतलं
कशात
फोनमध्ये. 15 नाही
चेक वरचं
आलं? हां ठीक आहे, चालेल चालेल. येतोय? एकदा ते सामान ऑन कर ना, वेबकॅमचा ऑडिओ चालू आहे. थांब. माझा येतोय? हॅलो, माझा येतोय? हॅलो हॅलो हॅलो, IoT चेक, IoT चेक, IoT चेक चेक. माझा येतोय. Yes sir, of course. हो. Yes. Let's begin. Okay. Sure. Mayank, Mayank. एकदा ऑन कर, परत एकदा ऑफ कर. नाही सर, नो सर. Yes. मी मयंक सर, मी IoT एक्सपर्ट टीचर आहे ICT स्मार्ट सोल्युशन आज मी तुमच्या समोर उभा आहे IoT and AI बद्दल सेशन देण्यासाठी. माझ्याकडून मला कधी काय मी त्यांना रिक्वेस्ट करतो की त्यांनी त्यांना इंट्रोड्यूस करावं. नमस्कार, मी वेद कुलकर्णी. मी पण मयंक सारखाच इंटर्न आहे नॉलेज पॉवर सोल्युशन्स मध्ये. आम्ही दोघं IoT मध्ये स्पेशलाइज करतो आणि आम्ही दोघंही इलेक्ट्रॉनिक्स रिलेटेड, डेटाबेस रिलेटेड आणि जेवढे पण इंडस्ट्री स्टँडर्ड रिलेटेड जेवढे पण आता लेटेस्ट ट्रेंड्स आहे त्याच्यावरती रिसर्च करतो. IoT and AI. तर मला स्टार्ट करण्यापूर्वी सगळ्यांना एक गोष्ट विचारायची, कोणी कोणी स्वतःचे स्मार्टफोन यूज केले किंवा त्याच्यावरती चालवला असेल किंवा काही कारणासाठी तुम्ही स्मार्टफोन यूज केला असेल, कोणी आहे का? जे आता right? तर तुम्हाला ऐकून कसं वाटतं की ते ऑलरेडी IoT सिस्टम आहे, म्हणजे ते प्युअर एक्झाम्पल आहे फॉर IoT. आता मी IoT करतोय तर तुम्हाला याचा फुल फॉर्म सांगतो पुढच्या स्लाइड. तर पण आपण एजेंडा बघून घेऊ आजचा काय आम्हाला. आपण पहिले व्हॉट इज IoT बद्दल आपण माहिती घेणार आहोत, पण एक्झॅक्टली IoT काय आहे. त्यानंतर आपण पुढे बघणार आहोत 2025 मध्ये IoT का मॅटर करतो. कारण की इट्स नॉट दॅट ते युजलेस आहे, काहीतरी कारण आहे ज्यामुळे आपण इलेक्ट्रिसिटी फ्रेंडली होतोय. पुढे आपण आर्किटेक्चर बघणार आहोत IoT सिस्टमचं. त्यानंतर इंडस्ट्री 5.0 बद्दल पण बोलणार आहोत आपण, कसं इंडस्ट्रीमध्ये इनपुट असणार आहे प्लस आपल्याला काय बेनिफिट होणार आहे इंडस्ट्री 5.0 ते पण आपण बघूया. आणि त्याच्यात आपण IoT प्लस एआयच्या इंटिग्रेशननी त्याला कसं एक मॅसिव्ह कॉम्बो करून आपण आपली काही यूज करू शकतो आणि मॅन्युफॅक्चरिंग इंडस्ट्री किंवा कुठल्याही ऍप्लिकेशनमध्ये त्याला यूज करू शकतो. मग पुढे आपण काही सेन्सर मायक्रो कंट्रोलर जे आपण जे तुम्हाला केस स्टडी पण बघायला भेटतील पुढे, त्याबद्दल आम्ही तुम्हाला एक ब्रीफ इंट्रोडक्शन देऊ. त्यानंतर रोल ऑफ IoT and AI हे आपलं एक टॉपिक आहे. IoT आणि AI कंबाईन करून आपल्याला कसं मदत करेल आणि आपल्यासाठी कसं बेनिफिशियल आहे ते आपण आज शिकणार आहोत. मग तुम्ही बघू शकता पुढे दोन केस स्टडी ठेवलेले आपण. एक ऍग्रिकल्चर सेक्टर मधली आहे त्याचं नाव आपण स्मार्ट कंवर्जन्स आणि दुसरी एक सिंपल डेव्हलपमेंट मोशन डिटेक्शन, जे आपण ऑफिस एज्युकेशनल सेक्टर किंवा असे कॉर्पोरेट ऑफिसमध्ये यूज करू शकतो. त्यानंतर आपण एक इंटरॅक्टिव्ह ऍक्टिव्हिटी ठेवलेली आहे, ते तुम्हाला पुढे पुढे कळेल. त्यानंतर आपण थोडंफार फ्युचर ट्रेंड बद्दल डिस्कस करणार आहोत IoT आणि AI त्याच्या रिलेटेड अलाइड मध्ये काय फ्युचर ट्रेंड असणार आहे ते. त्यानंतर आपण रॅप अप करू एक Q&A सेशन. सो लेट्स स्टार्ट. सो व्हॉट इज IoT? फर्स्ट ऑफ ऑल IoT म्हणजे इंटरनेट ऑफ थिंग्स. आता ह्यात दोन मेन इम्पॉर्टंट टर्म्स आहेत, दॅट इज इंटरनेट आणि थिंग्स, राईट. तर इंटरनेट म्हणजे काय, आजकाल आपण सगळेच इंटरनेट यूज करतो. इंटरनेट म्हणजे काय, आपण सिग्नलशी जोडले जातो. आपल्याला एखादं ऍप्लिकेशन गुगल सर्चिंग करायची असेल तर आपण गुगल सर्चिंग करतो, किंवा आपल्याला युट्यूबवरती एखादा व्हिडिओ बघायचा असेल आपण व्हिडिओ बघतो, किंवा आपल्याला सोशल मीडियावर ब्राउज करायचं असेल आपण ते करू शकतो. तर इंटरनेटचा हा भाग झाला आणि दॅट इज रिलेटेड टू कम्युनिकेशन सॉफ्टवेअर. बट थिंग्स म्हणजे काय, आता आपण आजूबाजूला बघितलं तर आपल्याला अवतीभोवती पण भरपूर साऱ्या थिंग्स आहेत. थिंग्स म्हणजे काय, आपण जे डे टू डे लाईफ मध्ये डिव्हाइसेस वापरतो ते म्हणजे शॉपिंग. आता आजकाल बरेचसे स्मार्ट थिंग्स निघाले. फॉर एक्झाम्पल एक बल्ब. आता आमच्या ऑफिसमध्ये आम्ही बल्ब ऑटोमेट करून ठेवले, म्हणजे जेव्हा पण त्या बल्बचा मोशन सेन्स होईल तेव्हा तेवढे बोलते बल्ब चालू होतील नंतर ते बंद होतील. अशा प्रकारची आम्ही सिस्टम करून ठेवली आणि त्याला प्लस आम्ही वॉइस असिस्टंट एलेक्ट्रासोबत कनेक्ट करून ठेवले. म्हणजे आम्ही एलेक्ट्राला कमांड दिलं, समजा आता एलेक्ट्रानंतर आम्ही रिमोट फोन मोबाईलने पण त्याला कमांड देऊ शकतो की माझ्या बेडरूमची लाईट चालू राहिली ते ऑफ कर. याचं जाऊन आपण सगळं आपलं टाइम वेस्ट करत नाही आणि समथिंग बनवतो. तर IoT म्हणजे काय? नेटवर्क ऑफ कनेक्टेड फिजिकल डिव्हाइसेस. हे तुम्हाला डिव्हाइसेस काय ते समजवतो. त्यानंतर ते आता इंटरनेट ऑफ थिंग्स मध्ये एक महत्त्वाची गोष्ट म्हणजे डिव्हाइसेस एकमेकांशी कम्युनिकेट करतात. म्हणजे आपण जर एकमेकांशी कम्युनिकेट करू शकतो तर ते त्यांच्या प्रोटोकॉलमध्ये एकमेकांशी कम्युनिकेट करतात. आणि ते आपण जर प्रकारे त्यांना कमांड दिलेला असेल किंवा त्यांना कोड दिलेला असेल त्या कोडला आपल्याला त्यामध्ये आउटपुट भेटतो. त्यानंतर devices with software and connectivity that collect, exchange and act on data automatically. जसं की मी तुम्हाला म्हटलं आपण एकमेकांवरती डिव्हाइसेस डिपेंडेंट आहे. त्यामधला आपल्याला जो डेटा येईल तो कलेक्ट नाही तर त्या अकॉर्डिंग आपण जे काही कोड केलेला असतो वगैरे त्यावरती ते प्रोसेस करून आपल्याला त्या अकॉर्डिंग आउटपुट येईल. आणि तुम्ही ते दोन आम्ही आपण बोलले गेलेली आहे त्यात लिहिलेलं आहे म्हणजे आर्किटेक्चर लेवलला किंवा फ्लोचार्ट म्हणू शकतो आपण. ते पहिले आता बेस लेवल आपण डिव्हाइसेस असतात आपण इनहँड वापरलो किंवा आपल्या सराउंडिंग मध्ये. त्यानंतर कनेक्टिव्हिटी. आता कनेक्टिव्हिटी त्यामध्ये काही प्रोटोकॉल असतात. फॉर एक्झाम्पल वायफाय वापरला आपण ब्लूटूथ वापरलं जिपी वापरू शकतो आपण किंवा एनआरएफ टेक्नॉलॉजी वापरू शकतो. अशी भरपूर प्रोटोकॉल्स आहेत जे आपण कनेक्टिव्हिटीसाठी वापरू शकतो. त्यानंतर डेटा प्रोसेसिंग. आता डेटा प्रोसेसिंग कोण करतं दॅट इज तिथंच पाहिजे तो मायक्रो कंट्रोलर. मायक्रो कंट्रोलर इज द ब्रेन ऑफ आर्किटेक्चर. ते आपण फर्दर बोलू डीपमध्ये. त्यानंतर इंटरफेसेस. आता इंटरफेसेस कसं की तुम्हाला आता एक्झाम्पल दिलं आहे आम्ही अलेक्साच्या ॲपवरून तिला कमांड देऊ शकतो. तर दॅट इज अन एक्झाम्पल ऑफ इंटरफेस. म्हणजे ते ॲप आहे UI आहे त्याच्यामध्ये आपण त्याला बोलून त्याला कमांड देतोय की हे कर. म्हणजे आपल्याला त्या सिस्टमच्या डिव्हाइसची कामाची गरज नाही. तर अशा प्रकारे आयटीचा फ्लो असतो. तर आपण मूव्ह करूयात पुढे.
तर आता ही स्लाइड मूव्ह करायच्या पहिले असे काही पॉईंट्स आहेत जे मी तुम्हाला क्लिअर करू इच्छितो या स्लाइड्समध्ये. आता महेशनी खूप आपल्याला खूप मस्तपैकी समजवलं की IoT कसं काम करतं. पण तुमच्या मनात हा प्रश्न पडला असेल की कम्युनिकेट करतात मग ह्याला कसं कळतं की हे आणि ह्याचं काम हे आहे ह्याचं काम हे आहे आणि डेटा कसा जातो. तर जेवढे पण थिंग्स आहेत तुमचा स्मार्टफोन झालं नाहीतर तुमचा स्मार्ट वॉच झाली नाहीतर कोणतेही इलेक्ट्रॉनिक डिव्हाइस जे तुम्ही IoT मध्ये टाकताय त्याचा एक ऍड्रेस आहे त्याला IP ऍड्रेस म्हणतो. इंटरनेट प्रोटोकॉल ऍड्रेस. तर दर एक जो इलेक्ट्रॉनिक डिव्हाइस आहे जो इंटरनेटला नाही तर कोणत्याही नेटवर्कला कनेक्ट होतो त्याला एक IP ऍड्रेस दिला जातो. आयदर तो स्टॅटिक असतो म्हणजे जो आपण स्वतः मॅन्युअली इनपुट केला नाहीतर DHCP म्हणजे आपण डायनामिक प्रोटोकॉल यूज करतो ज्यामध्ये आपण जेवढे पण IP ऍड्रेसेस आहेत ते ऑटोमॅटिकली ऍडजस्ट होऊन जातात. तर असं करून जेवढे पण डिव्हाइसेस आहेत ह्यांना जसं आपल्या माणसांमध्ये नावं असतात नावाने आपण कोणाला तरी विचारतो नाहीतर बोलतो तसंच ह्याच्यामध्ये जेवढे पण थिंग्स आहेत हे एक दुसऱ्याला त्यांच्या IP प्रोटोकॉल ऍड्रेसनी सिम्युलेट करतात आणि त्याच्यामुळे ते एक दुसऱ्याशी कम्युनिकेट करतात. आणि मग जेव्हा हे सगळे जे थिंग्स आहेत हे सगळे एका मेन मायक्रो कंट्रोलरला कनेक्टेड असतात. मग हे मेन मायक्रो कंट्रोलर कनेक्टेड असतं वायफायशी. वायफाय म्हणजे काय की एक गेटवे असतो ज्याला होम गेटवे म्हणतात. होम गेटवे म्हणजे काय जेवढे पण तुमचं फॉर एक्झाम्पल ही जी रूम आहे समजा इथे जेवढे पण LED असेल ते एका मेन मायक्रो कंट्रोलरला कनेक्टेड असेल. ते मेन मायक्रो कंट्रोलर कनेक्टेड असेल त्या गेटवेला. गेटवेचं काम काय गेटवे जेवढे पण हा डेटा आहे हा इंटरनेट म्हणजे वेगळे जे वर्ल्ड वाईड जे वेगळे नेटवर्क आहे तिथं पास करतो आणि ते प्ले करतो. आता पुढचं झालं डिव्हाइस सेन्सर तर कनेक्टिव्हिटी. तर डेटा प्रोसेसिंग मध्ये पण वेगळे हा जो डेटा पुढे केला जातो हे वेगळे सर्व्हर्स आणि डेटाबेसेस मध्ये स्टोअर केला जातो वेगळ्या फॉर्मॅटमध्ये. काही XML फॉर्मॅट असतो काही वेगळे टाईपचे फॉर्मॅट असतात. स्ट्रक्चर्ड डेटा अनस्ट्रक्चर्ड डेटा असे वेगळ्याच फॉर्मॅटमध्ये तो स्टोअर केला जातो. आणि मग तोच डेटा जर आपल्याला पुढे जाऊन यूज करायचा आहे तर शो करायचा आहे तर इंटरफेसचा यूज करून इझिली युजर फ्रेंडली वे मध्ये आपण तो पोर्ट्रे करू शकतो.
आता आपण बघतोय ते बरेचसे एक्झाम्पल आहेत. स्मार्टफोनमुळे पण आपला आजकालचं आयुष्य खूपच झालेलं आहे आपण पाहू शकतो. आता IoT फक्त स्मार्टफोन किंवा इतर इंडस्ट्रीची लिमिटेड नाही. त्याला लिमिटेशन काहीच नाही. त्याला तुम्ही तुमच्या घरात इम्प्लिमेंट करू शकता त्याला तुम्ही तुमच्या ऑफिसमध्ये ते कारमध्ये सुद्धा इम्प्लिमेंट होतोय. अशी पण टेक्नॉलॉजीवरती त्याला काम सुरू आहे. म्हणजे आपलं बेडमधनं उठल्यापासून ते बेडमध्ये झोपण्यापर्यंत सगळं आपण कशा प्रकारे त्याला ऑटोमेट करू शकतो. कसं आपण आपला टाइम वाचवू शकतो. आता फॉर एक्झाम्पल समजा सकाळी झाली आपण उठलो की या टाईमला आपल्या कॉफी भेटतो त्यावेळेला आपला कॉफी मिक्सर चालू होईल किंवा एक आपल्या डिनर चालू होईल. या प्रकारे मध्ये एखादा सांगतो ना, जर तर इथं वेगवेगळे पॉईंट मेन्शन केले रिअल टाइम डेटा. आता जसं की सेन्सर आपण डिप्लॉय करतो फील्डवरती, तर ते काय करतात, ते रिअल टाइम डेटा. आता आपण एखादं एक्झाम्पल घेऊ ऍग्रिकल्चर. तर ऍग्रिकल्चर मध्ये जेव्हा क्रॉप आपण टाकतो ग्रो व्हायला, तर त्याला वेगवेगळे पॅरामीटर असतात. फॉर एक्झाम्पल टेम्परेचर झालं, ह्युमिडिटी झालं, पीएच झालं, त्याचं पीएच लेवल, असे सगळे पॅरामीटर्स असतात. किंवा आपण स्मार्ट वॉचचा एक्झाम्पल घेतला, ते पण एक आयओटी डिव्हाइसच आहे. स्मार्ट वॉच म्हणजे आपण ट्रॅकिंग करू शकतो की आपण किती सेन्सर चाललोय, आपलं किती कॅलरीज बर्न झाले, आपलं बीपी काय, बीपी रेट काय आहे, आपला हार्ट रेट काय आहे. तर हे सगळं रिअल टाइम मध्ये चालू असतं आणि ते त्याच्या रिस्पेक्टिव्ह डिव्हाइस किंवा इंटरफेस मध्ये स्टोर होत जातं. म्हणून त्यामधून आपल्याला रेट पण भेटतात की माझ्या या एडिट मध्ये एवढा हार्ट रेट होता, आपला बीपी रेट होता. त्यानंतर ऑटोमेशन म्हणजे त्याच्या आपण आता आपला स्मार्ट परत एक्झाम्पल घेऊ. त्याला असं सेन्स झालं की आपण डिहायड्रेटेड आहोत, तर त्या वॉचमध्ये आपण नोटिफिकेशन येतो की तुम्हाला पाणी प्यायची गरज आहे. त्यानंतर एफिशियन्सी. आता आपण जेव्हा एखादी वस्तू वापरतो रिअल लाईफ मध्ये, तर त्याची एफिशियन्सी पण माहिती लागते. तर हे जे काय मी स्मार्ट वस्तू तर त्यामध्ये अशा प्रकारचे त्यांचं यूज केलं जातं. ऍक्टिव्हेट डेटा देतात की त्यावर आपण आपण सगळं ऍक्शन घेतलं जातं. स्केलेबिलिटी. मग स्केलेबिलिटी म्हणजे मी तुम्हाला म्हटलं फील्ड मध्ये आपण त्याला वापरतो. आणि आयओटीची एक सगळ्यात मोठी गोष्ट अशी आहे की एक रिपोर्ट आहे, एक मॅन्युफॅक्चरिंग कंपनी रिपोर्ट पब्लिश केला होता आता नियर अबाउट फेब्रुवारी एंडमध्ये. तर त्यामध्ये त्यांनी असं मेन्शन केलेलं होतं, त्यांनी त्यांच्या कंपनीमध्ये आयओटी इम्प्लिमेंट करण्यासाठी इन्व्हेस्टमेंट केली होती. तर त्यांना ते इम्प्लिमेंट केल्यानंतर त्यांना हे जाणवलं की त्यांचं 15% to 25% ऑपरेशन कॉस्ट वाचते. म्हणजे आणि त्यांचं जे आपण म्हणतो ना क्वालिटी अँड ऑल, ते तर वाढलेलं आहे. म्हणजे त्यांना आरओआय खूप चांगलं भेटले, म्हणजे रिटर्न त्यांना ते काय म्हणतो त्यांना बेनिफिट झाला आणि त्यांच्या कंपनीला प्रॉफिट होणं चालू झालं होतं आयओटी सिस्टममुळे. म्हणजे त्यांना आयओटी बद्दल कळलं होतं, मग त्यांनी विचार केला की आपल्या इंडस्ट्रीमध्ये इम्प्लिमेंट करतो. तर त्यानंतर अजून एक काय असे पण आहेत आपल्याकडे की बाय 2030 म्हणजे 2030 पर्यंत 29 बिलियन डिव्हाइसेस आयओटीशी कनेक्टेड असतात. म्हणजे आता आपण नवीन सोसायटीमध्ये पण बघतोय की एकमेकांच्या घराचे कॅमेरा पण एकमेकांशी जोडलेले आहेत. म्हणजे आपण आपल्या आपला लॉबीचा कॅमेरा असेल किंवा काही असेल, तुम्ही हे सगळं कशाने शक्य, हे सगळं आयओटीचंच कमाल आहे. पण आपल्याला ते माहिती नसतं की आपण जे काय करतोय, जे काय आपण त्याला ऑटोमेशनचं नाव देतो. ऑटोमेशन इज अ डिफरंट थिंग आणि आयओटी इज अ डिफरंट थिंग. आता ऑटोमेशन म्हणजे काय? ऑटोमेशन म्हणजे आपण एखादं सिस्टम क्रिएट केलं, मेकॅनिकल मायक्रोकंट्रोलर दिला. त्या मायक्रोकंट्रोलर मध्ये आपण सिंगल रनिंग टास्क दिलं, तुला त्याला कोड करून आपण आता डेव्हलप करायचं आहे. मग तो 24 तास 24 वर्ष ते एकच काम करत आहे. आणि मग त्याला मध्ये त्याचा डाऊन टाइम मध्ये त्याला मेंटेन करा, त्याला पार्ट बदलायची गरज असेल तर पार्ट बदला. आणि आयओटी काय आहे, आयओटी मध्ये वेगवेगळे सेन्सर डिव्हाइसेस, त्यानंतर क्लाउड प्लॅटफॉर्म, त्यानंतर युजर इंटरफेस, हे सगळं वापरलं जातं. प्लस ऑटोमेशन म्हणजे ऑटोमेशन प्लस जे सॉफ्टवेअर किंवा आयटी प्रोडक्ट आहे त्याचा यूज करून हे आयओटी शब्द बाहेर पडले. जसं मी तुम्हाला एक्सप्लेन केलं, ह्या दोन तीन कॉन्सेप्ट आहेत, इंटरनेट आणि थिंग. तर ते अशा प्रकारे रिलेटेड आहे. आणि अजून एक स्टँडर्ड आहे ते $1.5 बिलियन मार्केट ऑक्युपाय करणार आहे. आपण बघत पुढे जर आता आपण आले आर्किटेक्चर ऑफ आयटी सिस्टम, तर मी So now we have reached to architecture of IoT system. As I told you, there are different devices. So where do in every system now this communication, there are also OSI models, CCIT models for that. But that is all back end thing. So I have portrayed it in a simple way for IoT. So here as you can see, there are three layers. They are the perception layer, which is also called as device layer. Second network layer, then application layer. Now, in perception layer, as I mentioned, there are various devices and sensors. Then a primary perception layer, like we place different sensors on field, and then we collect data transferred to the microcontroller or the brain of the system. So then where the network layer comes into the picture. So what does network layer do? And it that various protocols can be used, such as 6G, Bluetooth, Wi-Fi, LLM, and many such things that by utilizing it, we can transfer the collected data. Now, it is a point that only collecting data doesn't make sense at all. What should we do? We take the data storage, take the data storage. What is the meaning out of it? We need something meaning, right? So, I think I'm going to see that how are we going to make the meaning of that data collection? So, as you can see, I told in a computer we use different protocols such as Bluetooth, Wi-Fi, level. And we can also use the 4G and 5G protocol. And in one of our cases, we have used 4G technology only. And in bigger case, we have used RF. We will show you further. And next comes the application layer. Now, what is the application layer? But before application layer, as I told you, the difference is the brain of system, right? Now, what is that brain? That is the microcontroller. This is the data for network. Then comes application layer. What is the application layer? All the applications used in our mobile, for example, Instagram or Alexa, Google AI, Gemini, ChatGPT, they all are in application layer. If they are user interfaces, so that in real time we can talk to them or we can talk to the system. And accordingly, we can make the decision using UI also, or we can also go and make the decision using the system. So, going ahead. I'm going to simplify this architecture of IoT system. As he explained, the perception layer is used for collecting sensor data. Now, there are second names for this system, such as perception layer is also called as hardware layer. Network layer is also called as communication layer, and application is also called as interactive layer, or where we can interact with the data and we can manipulate it to our advantage. So in perception, we see all the hardware like sensors and integration of them and how they will transmit all the physical systems that we can hold in hand comes in perception. It comes sensors, there are some controllers and all the programming for the sensors is done in perception layer. Then the network layer. As I told you before, there is an IP protocol. So for each device of perception layer, there is an IP protocol. For that, then by using that IP protocol, it connects to the network layer or communication layer, where it communicates either wired or either wirelessly towards a main switch or a modem. So once this system is connected to a main communication system or hub, it transmits the whole data that is connected from our IoT hub towards the application layer, which comes into database, where you have heard the different aspects such as big data and other things for databases. Here comes the application layer, where this data is sent to that database. Once it is on database, it can be accessed towards various devices, which we can give authorization of who can access and who cannot. Here in application layer, what we can do is manipulate data in such a way that we get the result what we want. For example, my colleague Mayank explained for agriculture. So, for example, we are growing wheat, and for wheat we require a specific water temperature, and we also require a specialized humidity. Now we don't want other factors, but we want that factor. Even though other sensors connect, what we can do is prioritize that two factors and make sure if the value goes up or down below the required value, it can trigger an alarm or a system which may be automate and which may streamline the process, which can be used for building more efficient systems. Yeah, yeah. So most of the time, embedded systems are used for their versatility. But yeah, PLC can be used. The difference in PLC is that it's already so bulky, and usually for industrial IoT, PLC can be used, and it lies in the can you see the side. Right. Uh, when the PLC comes in perception layer, where all the sensors are connected towards the PLC. And as you know, PLC has a network modem. We can connect a network modem to it. So using that network modem, it connects to the internet, and which therefore we can access the data at application layer.
So irrespective of PLC, embedded system or any other system, it can be used as PLC comes in hardware layer. So most of the time it is flexible, and that is one speciality of IoT, that whole system is quite flexible.
In this case, you can have microcontrollers by PS. In short, like it is a part of architecture which can be made up by. So now we come to the evolution, like we have discussed about Industry 5.0. So like there are previous years also from which we have come to now Industry 5.0. So let us start with this analogy like Industry 1.0 to 5.0. So initially in 1760s, Industry 1.0 was implemented in the industry. Now what is this industrialization phase like? In industry, researchers or engineers came to know that we can use different technologies, or we can make some system through which our or human or manpower can be reduced. Like we say, there are some risky tasks also in the industry. So then keeping humans is quite a risky. Like
Mining.
yes, but we can take example like human nature is precious, right? So we can make such system through which we can automate our work or make it simplified. So in 1760s, first mechanization of water and steam power. So during this industry 1.0, there was system that used to run on steam power, like water was evaporated, and with the help of that steam, the system would work, and basically these were single running tasks. Means they had a dedicated task, they used to run it subsequently and daily on daily basis. Going forward to 1870s, Industry 2.0 became existed. And in Industry 2.0, we discovered that we can also make the system using electricity. Right? So, systems are made that you will utilize electricity, and based on that, customizations were made, and that systems were deployed to the industry. Therefore, as the industry makes more profit and more scalable in their own. Going forward to Industry 3.0 in 1969, here where the first time robotics came into the picture. Now, I would also like to add one point here that as I am talking about IoT, IoT is a mixture of we can say three fields. One is first is mechanical engineering, second is electronics and telecommunication engineering, and third is what is this computer or IT, information technology or computer science. As we can see in the different that mechanical engineering lies here, electronics and telecommunication lies here, and then CS computer science or IT lies in the application layer, according to the layer. So coming back to our point, Industry 3.0 is the place where robotics was first time introduced. Like we can see there are different we can take robotics in the industry, like in automobile industries there are vehicle assembly machines, what is the assembly line in technical terms. So, using computerization now, robot or machine, we just make them and they will make logic for them. That is not the thing. They do be computerized. So, in Industry 3.0, computers and robotics together make this evolution into Industry 3.0. Now, coming into Industry 4.0 year 2000. Here where the IoT came into picture. Like till Industry 4.0 2003, different cloud platforms, different social media platforms, anything. The technology has been so advanced that engineers and researchers came to know that it can integrate these features also in our industry, or it can make our life easy and make more productive in our industry or field. Now, using agriculture, internet on use, as I mentioned, what is internet, then data analytics. Now, as I am talking that only collecting data doesn't make any sense. We have to make something meaningful output from that data. So, here data analytics was used, like the data collected by our visualizing that from the UI or different platforms. And then connectivity, like connectivity between different devices or sensors. Then moving ahead, we are up to 2020, like Industry 5.0 is implemented, but it is not that fully developed. Like it is in development stage. Like in Industry 5.0, we are seeing that now AI has boomed. What is AI? AI is artificial intelligence. What is artificial intelligence? artificial intelligence is a software or a thing or a language that is made by humans to make that thing or software uh, capable to make the decisions like humans. So I would like I will give one example ahead. So in industry 5.5 we are saying smart customization. Now what is this smart customization? This is where that I am saying IoT and AI. We are talking in this session about IoT and AI. Of combining these two things and making smart customization like in industry 4.0 we can see IoT. We make one system to customize it. We have to change the devices and we have to reprogram it, right? So it does not have that capacity that can make decisions like human, like I can do this, or I should take this decision now, or I can customize this process like this. Integrating an intelligence that can make the human effort less, or which could be little complete. So that thing is done in Industry 5.0. I would read the definition first. Industry 5.0 is like the next industrial revolution focused on human-centric collaboration. That I told you that making our life company more productive, more scalable, and more reliable. That is human-centric collaboration. Sustainable. That we should sustain and we can make more productivity out of that and resilience by integrating advanced technology with human creativity and skills in manufacturing to beyond. And not only manufacturing sector, it has diverse applications. It can be used in diverse, it can be used in a kind of like USP, blood cancer, and everything. One thing is just this much effect. So it can track all our body factors like diabetes and heart rate. It is like smartwatch only, but smartwatch is also little this much inside. And ring is you can see this much. So there is different like technology evolving day by day, and we are seeing the all technology. So this was all the industrialization that we saw industry 1.0 to industry 5.0. So moving ahead, I would like to ask Vivek to continue this topic.
So yes, as you may know now, we are going to discuss the lowest layer, that is the physical layer, which is sensors and microcontrollers. Now, as are one of our asked that PLCs can be used. So instead of microcontrollers, you may imagine PLC for some industries where it is applicable. So yeah, for sensors, what are sensors? Sensors are the device which sense the physical changes in the environment and convert them into digital data. That or the data which is accessible by a computer or a microcontroller. Then these are various types of sensors. It may be temperature sensor, it may be humidity sensor, it may be pressure sensor. There are various different types of sensor which use different properties in them to change the physical changes into digital changes and convey them so that we can use that data. Now here, for example, the common types are temperature. Well, the temperature can be measured using DST11 or LM35 sensor, which is a prototyping sensor. Humidity can be used by DST22. Well, the best thing about DST22 is that it can be used for both temperature and for humidity sensor. Then for motion, PIR sensor is used for detecting motion differences. As Mayank mentioned that we have in our lab a bulb which can be triggered by motion. So PIR sensor is fitted inside the bulb. So when it detects motion, it automatically turns on, and when there is no motion, it turns off, saving electricity and saving us money by reducing the cost of electricity bill. Then light sensor, LDR, which is light detecting resistor, which changes its resistance based on the intensity of light on it. Various TVs and various screens use these to adjust the brightness according to the environment the viewer is watching, or it may be used for at home IoT for checking if the sun rays falling from outside is too much. Then we can sense it using the LDR and make sure that it is according to our requirements. Then soil moisture. Well, in our case study also we use capacitive soil sensor, where there are two types. One is resistor and one is capacitive type. We have used capacitive type because it is what we say latest and it is more precise and more efficient, where the capacitance changes according to the moisture present into the soil. Then comes the microcontrollers or PLCs for our application. Well, mini computers that read sensor data and processes it and act or transmit. So the popular are Arduino Uno, ESP32 and STM32, which is an industry grade microcontroller, which is STM32 or STM32. Well, these microcontrollers are the what are used for programming the sensors and getting the required data. It may be also be used for calibrating sensors and making sure that they are microcontrollers also are responsible for connecting the network to our hardware devices. So microcontrollers do both tasks, integrating the sensors also and connecting to network also. So they play a pivotal role in IoT systems. And here, Arduino Uno, which is beginner friendly, which is used for prototyping or student use. Uh, Generally, Arduino Uno is a very beginner or easy to learn microprocessor, but it has its own limitations. So there, after that comes ESP32, which has built-in Wi-Fi or Bluetooth. Well, if you are using Arduino Uno, you have to add external network cards to it. But if you are using ESP32, it has built-in Bluetooth and Wi-Fi, so it can be used easily and integrated easily in IoT systems. And then comes the STEM32, which is an industry grade sensor. So no doubt it is better than most of the example or prototyping sensors. Then there comes the industry grade and prototyping microcontroller, which is going to explain my mind.
So as my question mentioned that Arduino and ESP32 are their computer processors, there are different industry and computers available in market. For example, so here explain so like industry grade, what is that purpose? Like in industry there are heavy loads or heavy work we are doing heavy work on it. So to sustain that environment, industry grade microcontrollers are like there are certified everything industry every part everything we use is certified. For example, ISO certification is there and different other safety certification and all. So the purpose of the microcontroller is that it should be sustainable and useful in hard conditions also and making its life greater as compared to prototyping. Now you can prototyping microcontroller also. And prototyping microcontrollers are usually made for experimental purposes. If you do something experiment on a prototyping microcontroller and then switch to the industry microcontroller, in that microcontroller also different sensors also right. So in prototyping microcontroller we see that the pins are given freely so that you can handle that microcontroller very easily. But in industry there are as you know in industry there is a vital role of the geographical area. Then space should be occupied that system or that circuit. So that कम से कम जगह पे हमें ज्यादा से ज्यादा आउटपुट मिल सके वो वाला नहीं है so in smaller geographic area that is that how many logical circuits how many you can fit in that small geographic area. So this was an overview of industry then microcontroller and controller example you added. So here I differentiate from electric microcontroller the brands are microchip STM microcontroller that is the one series my colleague mentioned that is STM32 STM32 then NXT, then Texas Instruments. You all must have heard about Texas Instruments. Then Atmel. Now I am going to talk about Atmel that is now combined with Microchip company. Atmel is also used in Atmel is also working prototyping microcontroller. Then Silicon. Now let us see some prototyping microcontroller. Here are the Arduino Mega. Arduino you can see here. And using one of our case studies. Then ESP826, then ESP32. We have used ESP32 also in one of our case studies. Then you get it ahead. Then Raspberry Pi Pico. Raspberry Pi also has different series. There is one model like Raspberry Pi 1, Raspberry Pi 3 model B plus. Then STM32 also comes in prototyping model. industry grade microcontroller, right? It is also used in so it is STM32 and it is also mentioned in programming microcontroller, right? So it is made in such a way that and also show you the how pinout are useful in doing that programming. So you can make experiments using that programming STM32. Like it is more powerful or it can handle and complete AI model. We are going to talk about IoT and AI. So where AI model is also a crucial part of artificial intelligence. So AI can be implemented in that STM32, whereas microcontrollers like ESP32 and Arduino can't handle AI modeling it, and it requires a lot of space and what is the computational power. So I was just mentioning that this point. So moving ahead, yes. And we saw this is a quick differentiation between both, like you can see it is investigate microorganisms and prototyping. Use case and set out investigate where the manufacturing industry or diverse application है heavy loads are done or in practical use cases prototyping are used for experimental purposes. Then form factor. Now form factor is like the as I told you the structure is different for industrial microorganisms and prototyping microorganisms. So there are some examples I mentioned DIT, QSN and TQS. Now what are these? You must have seen washing machine have DIT, like what DIT means. It is dual inline package. So in washing machine or TV, these ICs are given whose form factor is DIT, that is dual inline package. Then QFN, that is quad slash low lead. Now this low lead is that lead method is not using that particular microcontroller and it is quad in shape, that is square in shape and flat in structure. Moving like CQFP. So, tall, quad flat, programmable device. The full form is like that. I will show you the example of this so that you can visualize them. Then going ahead, cost. We know industry grade microcontrollers are expensive and programming are budget friendly for experimental purposes. If we find like industry grade microcontrollers, the cost automatically decreases. So that is why it is mentioned like that. That durability, as we know, they are investigate microcontrollers, especially when it was hard conditions, so it can survive it. And prototyping microcontrollers can only survive, they can survive up to some extent, like half year, 1 year. After that, some issues that creating in it, as it can be server that condition or heat, like this time of sustainability and low. When you next certification, I told you I have a certification for industry microcontroller and prototyping have certified by their own manufacturer company. Then programming interface, there are different programming interfaces for industry, for example, JPEG, SWD, and for prototyping, you can use different software platforms by their manufacturers. For example, for Arduino is used for Raspberry Pi, Arduino is used. Then production readiness, then customization and community support. And community support is moderate to low and what extent it can be used. Going ahead, this is the as I told you, I will show you the these are independent microcontrollers. This is the QSP that I told you, quad slash QSN.
Quad slash knowledge.
CQSP is that structure, last one. So these are the different industries microcontrollers. This is a STM32 that we saw, and the next is the microchip. Microchip PIC 16 was shown here. So moving ahead, this is the computer DSP model. DSP model, I would like to show you direct in the microcontroller itself. I would like to showcase it first. So you are seeing this, I think this dual inline side. That is why not mentioned it separate. So normally I think gate is removable.
Yes.
Yes, this is removable only. This place is that I told. Yes. Going back from here prototype microcontroller start. So here you can see as I mentioned there are very three modern features. This is that microcontroller. So I would like to mention a special thing about the Raspberry Pi that it can handle a separate OS on itself. And you can upload Windows OS on it, it can run independently just to connect it to the screen or TV, it can run as Windows software. You can also run just yes. So it is that much capable. But now there would be a question, it is so much capable that why it is not using seamlessly. It has some limitations, like the structural area is also more. And this is especially meant for higher experimental so meet the higher experimental expectation. So this is the modern 3G plus and that is Raspberry Pi Pico W. You can see Raspberry Pi Pico W and Raspberry Pi Pico here and we have called them basically. So moving ahead, these are the Arduino series, this is Arduino Mega, this is Arduino Uno, in which DSP IC is used, and this is the structure. And you can see this, why I am taking this for the experimental purposes. The pinouts are simplified here. Like this is the assembly technology, like internally connections are made. And using this, we can use jumper wires, connect them here. Here are the power rails, here are analog pins, here are digital pins. The PWM pins, this we can connect different sensor devices to this special microcontroller. This is Arduino Uno, this is Arduino Nano, this is Arduino Nano Micro. So moving ahead,
Now,
hand over this.
and this is ESP32. As I talked before, this microcontroller is special. Why it is special? It has inbuilt Wi-Fi and Bluetooth. As you can see in the package, here is the main microcontroller light. It is an SoC that is on chip on system chip on chip microcontroller, where Wi-Fi is embedded inside on chip and Bluetooth is also there. Here various digital pins and GPIO pins are there. RF pins for communication purposes, and here are the connection pins. For example, some circuits or sensors require internal connection. For that, they have given power rails that is 3 volt and 5 volt is came from the in, which we can connect from the USB connection, and then we can access the Wi-Fi protocol from inbuilt programming memory, where we can program it for specifically connecting to with various Wi-Fi and Bluetooth also. Usually Bluetooth version 5.0 zero is used here, and here different power and different resistors are used.
So I have showcased some images showing the pinout. Like I wanted to say that in a microcontroller also programming, the single pin consists subsequent function also. Like for example, if you consider this pin one of our Pico W, you can see its functions like a general purpose input output. It is PL37 interface, PC1, it is I2SC SDA, where it is also used as UART transfer. Now the main purpose showcasing this image is that the pin of the distributed like this and single pin can also perform multiple functions. So going ahead, this is the pin out that I explained you in previous slide about Arduino Uno. This is about
ESP32.
that we explained in brief. Again comes the topic industry grade sensor and
Prototype sensor.
So as you have got the idea that what are industry grade and what are prototyping one. So I will not give the definition, you will just see the examples of it now. So you can see here there are different types of sensors, current sensor, temperature, humidity, and you can see the industry grade one with prototyping one. For example, if we consider this category that is temperature sensor, you can see that RT/PT answer is used in industry grade. You must be familiar with this. And for prototyping, we can use DSP22 that is we have used in one of our case study also. So here you can see it. Then moving example of similar. Yes. Right. So when we talk, as I mentioned, when we talk in industry grade stuff, then precision matters. It is the utmost or in case of IoT or IoT sector, usually it is used in healthcare, in smart watches. So we can see that they are activating these activities. That is the use. And speaking about this thing, they are obviously most important. Industry three microcontrollers are customized and made for that purpose only. In programming also we get accurate result, but we can't sustain that environment. Huh? So that is why industry three microcontrollers are increased. Essential and increased.
Well, as we see, we are going to see a case study about agriculture. For example, we use capacitive soil sensor in our case study. So what will happen? This is a capacitive soil sensor. So as you see, it is a basic sensor used for prototyping. But now you want it for industry. You want it to use for your vertical farming or different greenhouse farming. So for that, you want to be your system to be as precise as possible because here usually these systems are used for prototyping and used by students. So here, if this fails, there is not much thing to lose. But at industry grade, if you plant it in a system which is not optimized, your crops may fail or the system you are running may fail, and that leads to your financial loss, and it may further lead to collapse of your ecosystem of what industry or what automation line you are carrying out. So the responsibility lies on sensor is increased, and that is why industries heavily test them according to the standards. They have very high standards, and if a device is not that capable, if it cannot surpass that standard, it is not accepted. But in this, it is as it is used for prototyping and education purposes, it is easily obtainable and very cheap. But in industry grade, a lot of R&D is used and lot of expenditure is used for manufacturing them. So that makes them not only makes them expensive, but also make them hard for the industry to incorporate them because they also come by their company standard. That is why industry grade sensors require a little hard time conversing between different microcontrollers. That is why it usually takes longer, but it is more reliable and more precise, and it can go a very long run. For example, as my colleague said, this only usually works for 1 year. That is the average, but industry grade may work for 10 years, and that is with precision up to plus minus 2% or plus minus 5% according to the industry grade or the test they have conducted. So that is the main difference.
And you can see the different sectors and building blocks of the IT system like we can jointly, you can see them in the process going ahead, these are all sensors again. I wanted to mention about that thing that you can see this is a gyroscope and our phone also has a gyroscope in it. So in photo it looks much bigger, but in real life it is this one. So you can visualize that in your smartphone. It may be like a small register or some component only. So the work is done at that level. So this is thermometer, this is ultrasonic sensor, this is RFID. We have used to RFID like in offices that are RFID card identified, that sort of thing. So moving ahead, we have already discussed that differences. So we'll move ahead. Now from the IoT and AI. So I will explain this also in short so that you can visualize that thing in a case study. After this case study will start. So what is IoT and AI? As I told you, collective data is not the thing. We have to make working out of that data. That way AI comes into the picture. So what this AI do, this is a different type of AI model in case, and that AI model will process that data and make some meaning out of it. For example, in our case study also, we have connected the data, the past, and based on that, AI is not implemented again. But if AI was implemented, we are working on it still. So if we have implemented what we will do, in future such condition repeat, it will have that backup. Like AI special quality is that it has a habit to learn. It learns continuously. Right? So intelligence is very like a human, so that it can also remember the past things and can also predict the future things. So this combination that used in different applications such as agriculture, industry, home, and smart cities. And the best example I can give now from IoT and AI was everybody has seen Nimbalkar robot 60 and robot moving with 60 robot also. So how it was made? It is not only the work of that we are trying to tripartite the robot is going to no, that is not the thing. You have seen that new scheme was also implemented in it. AI is also used so that that is the reason why we can use that digital technology. So can you correlate with IoT and AI? We can visualize in that 50 robot that it can do work like human, it can cook, it can write, it can do many sort of things.
Well, I will like to add from it. Well, what you may ask me what is AI? AI or artificial intelligence? That means a machine that is able to mimic human cognizance. So for that, AI is used, and the sub part of AI is machine learning, in which we give him a large number of database or large values, feed them, and it learns itself. AI is nothing but an algorithm which works and which deploys and it governs like a human sitting, like an HMI or human machine interface. It automatically adjusts everything. It changes the value according to it if it wants. But in some situations, if we had something that we hadn't had before, it is a new thing. But for this system, what we use as mentioned previously, that in application layer we store all the data in database, that is the big data. So we use that big data to train our AI models using machine learning. So using machine learning, we develop different algorithms, develop different things. And this machine learning is divided into three parts. That is volume, variety, and volume, variety, and what is a vision? So volume means the total amount of data. When the big data is nothing, we cannot define big data as a size. It cannot be 1 petabyte data. It can't be 1 zettabyte of data, and then we call it a big data. A big data is the thing that contains these three, which is volume. The volume must be greater at a very large scale. That is using multiple databases. Second is the velocity. That means the value of incoming data must be increasing. That means let's say 12,000 units of data came, then 15,000, then 20,000. Such the exponential growth, and then variety means not only just let's say a number, let's say a character, and different types of value data is added. So these three characterizes makes big data. So what we use is machine learning to use this big data and implement it using our AI. And when we use AI, we implement it in IoT. So what it does, now the sensors are giving data towards our system, and that data is used by artificial intelligence. Then that artificial intelligence decide what has to be done to our system, and then it changes, and then it interacts. So instead of manually switching your TV, you can give voice command, or even if you walk in your room and you want that your TV wants on and this channel is, for example, news channel, you can set that, and then when you come home and the sensors detect you are home, the AI can switch it automatically. It can start your coffee machine. It can do everything, and AI manages all. You don't have to add or make human intervention in it. That is the main specialty of role of IoT and plus AI.
And one real life example I have mentioned is robot. So Toyota company has also built a robot like that humanoid robot. They have the really old method of a data collection utility, no data collection is totally dependent on sensors. Data processing PC or automatic modules are used in analogue integration, isolation models, class SPM. These are the AI models that can be implemented for this process. This is the process in that IoT. So moving ahead, you can see there are many layers of available for audio and voice processing, like video input in text, data, design voice, can also be your voice and all. So here comes our case studies where we have integrated all these software to portray you. So as components, so you are familiar with that. And that part of we told you that we are using that in our case study. So here we have the GST 32 for capacity converter and GST 22 sensor. So moving ahead, I would like to ask you to brief explain architecture.
Well, in this architecture, what we do, each node is divided between the field of agriculture sector. Each node comprises of sensors, microcontroller, and its communication device, which in here is NRF. So here, each node is deployed in the field. What it does is that all the sensors get the data and store it into the microcontroller. Then what microcontroller does, it connects to the NRF system, which is physically attached to the microcontroller, and then the data is sent towards a main system, or what we say is these nodes are slaves, and what a main computer is a master. It's all the data is sent towards the master. Here, for example, these are the different nodes. In this node 3, we have specifically added a motor which uses for automatic irrigation. If a value goes below a certain point, the irrigation turns on automatically. From this, at receiver end, as you know, we use NRF. So for this NRF to NRF, we use different pipeline channels so that all the data from different nodes don't clash and we don't lose the data. After that, when it goes to the receiver, it is then demodulated, and then after demodulating it, the what ESP does is convert that data, and after converting, it uses Wi-Fi. As I said before that ESP has inbuilt Wi-Fi, so it uses Wi-Fi to connect to a router, and by router, then it uh, connects to the internet, and then it connects to a database. For your example, for this prototype, we use Blink Cloud integration. Blink is a free to use.
This is the real time that was collected by that period of time. And you can also see different pictures that are collecting data like 1 hour, 6 hours, 1 day ago, 1 week, and so on. So that you can export that data to extensive and able and processing and decisions, and we can make more and more profits, and our profit is also good. Right. So they are also working that things like does the crop need fertilization now, does it need water now, and all that sort of thing. So there are different platforms. There is also I have got the miniature version of that. This the system we saw is big one, right? So it is not routing, so we can go ahead. Like Nimbalkar is one cloud platform. Then Arduino cloud that is made by Arduino company. So these are cloud platforms. Then so as we tell you the whole workflow like from sensor it goes to the RF models, and RF models is that data to the main base station. Then base station uses Wi-Fi and sends that to the cloud platform, and we can utilize the data using user interface. System is overview. This is the actual three-node system. This is the bunching. It was not possible to showcase here. So we have got the miniature version, and you can see here in the table. This is single node that collects the data and sends this cells only. Here you can see here are three nodes, and this is the receiver, and this was the structure. Like we have used spots to portray the field. So I would like to show you a setup of it. There is the dashboard that I showed you. This is the real time one that at that time the system was active. This is the MATLAB animation which we did. So going the I showed you the main cloud, and this is the serial monitor output.
The
Data is connected and processed on serial monitor.
well, serial monitor is used for debugging purposes. So serial monitor is not stored towards the user. It is only for developer to access or debug the system. That is why only we have stored here for development purposes. This screen is shown towards the user, and user uses this screen to control the system.
Like you can see any number performance, you can manually do it from the app, cloud system. That's how you are able to
System.
vote. Going ahead, here comes the second case study. I am not going to talk this about sincerity. I would like to let expose the use that I have simulated this case study, especially for you that actually the exploration also be done on the software. So, okay, so as you can see, here is the code that is used in this particular case study. This case study is about that I have mentioned that this system can be used in office as well. Like how many people have entered the office? Like footfall. How many person has entered the office and we can find the amount of people. And I have kept this one very simple because our previous one was a bit complex one. So I can simulate it here and you can see this is the code and we will start simulating. So it will first check the code and yes, now you can see here as I have seen here, started simulating and you can see as I move, here you can see it is growing. Right? I have not used OLED display in this, but in actual one you can see that sound on the OLED display. So this was the thing. If motion is detected, the LED will glow, if low, then it will turn off. So coming back to our PCB, as I mentioned, I use OLED display typically you can see here. If you want to change typically you also showcase after the lecture. So moving ahead, this is the same diagram. This is the actual system and you can I will show you the video here so that you can get what I'm talking about. So as you can see, motion is detected and it is closed and sound is increased. Again, motion is detected, motion is detected and sound is increased. As many times people pass through it, it will increment the count by one.
Well, this is a basic prototype system. In this system, we can add different things. If we integrate IoT in it, what we can do is when a person walks, the doors can open automatically, or we can take the attendance by using the biometrics. So once a person walks, the camera in front will turn on and take an image. Then using facial recognition, it will mark his attendance, and then automatically once the person passes, it will close, saving energy. So by this method, we can use IoT in this basic system.
So moving ahead, here are some now industrial activities. Like I want you all to visualize and you are from that diversity, somebody is teaching here, somebody is working and working professional. Can you imagine the combination of IoT and AI? If you make something using this, then how can this be implemented in your industry? We can automate that and make it smart, make it productive. So just 2 minutes, can you think about or give us like you can correlate this knowledge with the industry or with the sector.
What will be your case study according to your industry? What do you think? How?
Instead of energy conservation, maximum energy users are regulation and use.
Yes.
So depending upon the attendance inside the room, can we set the temperature and heat flow?
Yes, of course. Actually, that system. Actually, company name Cisco, which is a networking company, has actually implemented this in their office. Which they have, what they have done is that in the San Francisco office, at Cisco. So what they have done is that connected even the lights, AC, everything to by Ethernet cable. So once it is connected to a database, they have implemented IoT index. So once a person walks in, if a meeting is going on, if the room is full of people, automatically the air condition is adjust to a higher level so that it can accompany that number of people. And once everyone leaves, the lights go off, the AC is shut down, and everything returns to normal. Everywhere they have placed sensors so that they don't need to manually turn on or off, and everything is automatically adjusted. Even the lights, even the to increase the productivity of the employees, what they have done is yeah, yeah, well, as you know, nowadays most of the AC comes with inbuilt connectivity. As most of them, I mean, from less than 3 years ago, this system was implemented, and it has now become an industry standard. So most of the AC that we use have this system that it can connect to Wi-Fi. Now, the development of the system is most of the time it is already done in most of the top industries like Google or Amazon or Cisco, for such example, have already implemented it on a small scale. That is their head office or something. They are scaling it up as it saves not only saves the energy but also makes the employee more productive. That is, if an employee needs more sunlight, it can dim the lights. If an employee wants this, it can adjust according to it. And as you know, productivity. Yeah. Yeah, 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 yeah. Yeah. Well, that will be variable. That means how much office cabins are there. Yeah, but if we assume things, it may be, as you say, 2 floors. It may take 30,000 once deployed industry standard in industry grade. So it may need, but that is variable according to the company cost and everything. It changes, but it is the approximately figure. These are different nodes. So as we explained, the nodes are separated out in the field. The- This is we use MATLAB simulation system. This 32. As I explained about the inbuilt Wi-Fi feature one, this is the one ESP32. Sorry, wait.
short, what are the future trends about it? So as we talk about IoT and AI, like with the by implementing the AI models, how can we be more productive? Then tiny ML is the tiny machine learning, so that it can be the AI models are in such a way that they can be implemented in small and programming microcontrollers also. As I mentioned previously, like ESP sorry, yes, ESP 35 Arduino can't handle that AI model. So tiny ML is used in that. Then moving ahead, blockchain identity. Blockchain identity is, as we had a conversation with Sachin also, that security is the main purpose in everything. So blockchain is a technology through which we can solve that problem. Our data will be encrypted and no ethical hacker, no one can tamper our data. It is anonymized, reset, and retrieved. Right? That can be only decoded and coded by respective microcontrollers that by using solid credentials. So more than digital twin, digital twin is a technology which actually implemented or being researched for the manufacturing industry. Like we can say virtual replicas for physical system simulation. Like we can see a whole manufacturing industry how it will work. So using this technology we can visualize everything in the software and simulate it. So
When in 5G and 6G integration, as you see, sometimes we get a network problem. So what we can do is using sensors, we can detect how many users are there in area, and we can then change our power plan according to the users. And then if there are less users, the less power will be used by the tower, and if there are more users, the more power will be used. By this, we can not only handle users efficiently and provide them with high quality of service or QoS, but it uses which allows high level applications and ultra low latency for critical applications. And sustainable IoT, well, the sustainability is now engineering strength. So using sustainable IoT, we can make energy efficient sensor and use green computing and save energy by using smart grids or different types of systems to save electricity on a mass level. And by using this, especially in metropolitan cities where there are a lot of light and light pollution and different types of pollution that accounts for electricity losses, where IoT can make it less and make the more system more efficient, and the cost also will be reduced.
ideology of sustainable agriculture is that it should work with technology. Like technology should not become behind like that. It should not refer to human level. And we know due to economic it is harmful for us and other animals also. So that should not be an issue. So that's sustainable agriculture. And moving ahead, if you have any questions, you can ask us or else we can wrap up the discussion. Okay, but I will take one more. If you want to connect us, you can connect us using this link. Thank you so much. Now, before voter sign, I would like to express my heartfelt gratitude to Mr. Sachin Nimbalkar sir for helping us, guiding us, and supporting us for and giving us this opportunity to make this wonderful session possible. It was not possible without our guidance support and all. I would also like to thank Mr. Mayank Kulkarni sir because who constantly motivated us and guided us for that sort of thing. I would also like to thank my colleague Mr. Lokshya for flawlessly handling all the technical things. Like you can also see that our technical from behind camera there is a person who is handling this. Thank you, Lokshya. And thank you to the audience for listening us. Uh, Thank you very for this
Question.
1 hour webinar. So I will take 4 to 8. Please scan this QR code and give your feedback about this session so that it will be helpful for us so that we will more and more useful session for you further. Thank you.
On behalf of AMI, thank you very much, my professor, and with Kulkarni for this like an insightful session. Special thanks to Professor Sachin sir, AMI team, and most of all, most important, all the participants for patiently listening and their support. Thank you.
I would also like to thank you so much for gave us this platform that we could not share our knowledge. So thank you. So please give your feedback on this QR code. And then thank you all.
सर हे रिले आहे.
रिले कशाला वापरतो?
रिले मोटर ऑन ऑफ करायला. हा वाला कपॅसिटी सॉइल सेन्सर आहे, सॉइल मॉइश्चर हे करण्यासाठी. हे वालं आपलं मायक्रो कंट्रोलर आहे विथ वायफाय. हे टेम्परेचर ह्युमिडिटीसाठी DHT आहे. हा आहे.
तुम्ही देता म्हणणार
थँक्यू सर.
कोण काढतो? कोण काढतो?
थँक्यू सर.
मोटर ड्रायव्हर आहे ते मल्टिपल मोटर हे RFID टॅग आहे. म्हणजे जे आपण बघतो ते अटेंडन्स सिस्टम्स असतात ऑफिसेसमध्ये, ते आपण कार्ड लावला की दार उघडतो, ते RFID मोड असतं सगळं. त्यानंतर ही आमची केसरी मोठी दाखवली मी तुम्हाला. त्यानंतर ही आमची फार्मिंगचं त्यानंतर हे रास्पबेरी पाय पिको W आहे. हे रास्पबेरी पाय पिको मॉडेल आहे. त्यानंतर हा Arduino Uno वापरला आहे. आता Arduino Uno मध्ये पण दोन टाईप्स असतात. एक R3 मॉडेल असतो आणि SMD वर्जन असतो. R3 मॉडेल आपण बघितलं त्यावरती DIC चिप लागलेली होती. आणि मग ते पण वेगवेगळे वेरियंट असतात. आम्ही जो केस स्टडी इम्प्रॅक्टिकल बनवलाय त्यात आम्ही इंडस्ट्री रेडी SP32 वापरतो.
डेव्ह सेट म्हणतो त्याला, इंडस्ट्री ग्रेड ब्रूम डेव्ह सेट.
Yes. As you can see, there are different chips. Yes, this is the chip. So they are simplified. You can use them this GPIO for the experimental purposes.
Yes. Using the
Of Raspberry Pi Pico, I use Raspberry Pi Pico, program this, and then make this chiplet. This chiplet is not available in market. I have made. So you can see here is my model, which is running the single code application, and this is what the output is. It is simply for power. What is your company? Like we provide you solutions regarding DevOps, Azure, or creating an IT solution basically. And apart from that, if you need any solution, you can contact our son. So he will guide you for the we are an IoT expert intern there only.
yes.
If you contact us, we will help you to make that.
Yes. We actually are currently researching about it. So as currently we are in the topic of artificial intelligence and IoT. नाही सर, आम्ही आमचं लिंक्डइन दिलं तर चालेल. नंबर लिंक्डइन आहे तर नंबर दिला
Trying
चालेल.
to implement an AI model in it so that we can portray and make it industry useful. Like India, farmers,